quite brilliant, and it's a real pleasure to be here. You asked us to introduce ourselves. I'm going to introduce myself very briefly, and I'm going to do it by describing my PhD thesis, which I did at Oxford University. I'm a Russian historian by training. I discovered that there was an institution called the Senate in Russia, created by Peter the Great. And between 1801 and 1803, Alexander I decided to reform the Senate. And there was a lot of excitement because some people thought that Alexander I, this is just in the wake of the French Revolution, was going to introduce profound changes to Russia. But nothing of the sort. The reforms went absolutely nowhere, and there's a real problem about figuring out what the Senate did. So I spent 5 years, including 1 year of research in Leningrad, studying a non-reform of a non-institution. And I concluded after 5 years that the Russian Senate, the most useful way of describing it was that it was a sort of retirement home for ex-lovers of Catherine the Great. That's my introduction to scholarship. I feel I've been kind of running away from this micro research for the rest of my life. And in the late 20s, in the late 80s, having taught about the history of Russia and the Soviet Union very enjoyably, it was interesting during the Cold War, it's a bit less interesting now. I suddenly had this very naive idea that it would be interesting to talk about history beginning at the very beginning, and it really was naive. I didn't know what I was doing, but I thought it would be fun. And that's a trajectory I've been on for 20 years, and it's been lots of fun. I coined this sort of slightly whimsical phrase, big history, to describe the idea of history at all possible scales. And in 2004, I wrote a book called Maps of Time, which was my attempt to tell that story. Now, I hope that what I say in this talk is appropriate. I hope it's engaging, but it comes out of this project. And it comes out of my attempts to place big history in a larger historiographical content, the place of what I've been doing and what increasing numbers of people are doing within the history profession, but in the long-term development of the history profession. I'm talking very much as a historian, trying to set this within that context. Just one other final introductory thing. I'm going to try to talk as clearly as possible. I'm always astonished at the linguistic expertise of Dutch people, but please, if you don't understand anything or I don't talk clearly, feel free to stop me. I'd far prefer you to do that in the middle of the talk and give me a chance to explain what I'm saying. And now I'm trying to wear a suit. I think I'm going to take it off. I'll feel much more comfortable. Okay. Big questions. I love the big questions. Historians, by and large, are a bit hostile to them. The big question, I suppose, that I want to talk about is what is history? What do we mean by the word history? And, of course, I'm going to talk about what history looks like in the light of my experiences of teaching big history. I want to talk more specifically about what I think are the revolutionary implications of a series of technological changes. They're changes in dating techniques. Now, you'll understand that with my Southern Californian students, I have to sometimes be very clear what I mean by dating techniques. I mean techniques for assigning absolute dates to past events. And what I want to talk about is what I think are the revolutionary and often unnoticed consequences of changes that occurred from the middle of the 20th century in our ability to assign absolute dates to events in the past. And that's what I mean by this phrase I've used, the chronometric revolution. And I'm going to argue that this is a revolution that I think people in many other disciplines have been profoundly affected by. Historians, I think, still have to take on board the significance of this revolution. And I will suggest that at the end of all of this, There is the possibility of a redefinition of what we mean by history, specifically human history, and I will suggest the possibility that there's a more rigorous definition of history sitting there. Throughout this, and I'm talking from a written paper which develops this argument more carefully, there's a sort of running dialogue with R.G. Collingwood, the English historiographer, simply because he raises many of these questions in a very clear form. Okay, chronometry and history. Collingwood, in The Idea of History, says historians deal with the past. Now, of course, that's far too general to be useful. He then goes on to qualify this. And in effect, what he says is that historians, I'm rephrasing here, historians deal with the datable past. In other words, the past, insofar as we can assign assign dates to events in the past. And if we can assign dates, then the past has some sort of structure. So it's this structured past, based on chronology, that historians deal with. Now, this is such a banal and obvious point that historians routinely forget about it entirely and put it out of their mind. What I'm going to argue is that chronology is much more foundational, and changes in chronology are therefore much more revolutionary in their implications for history. Chronology is foundational, and we forget about that at our risk as historians. Now, I want to offer a very simple analogy to suggest why I think chronology is important. And this is the analogy of the past as a sort of cave that we're trying to look into. It's a simple metaphor, but it captures some of the things I want to say. If you look into a cave, we can partition what we see into two domains. The first domain is at the entrance of the cave, where sunlight may give some illumination. You can see details, you can see structure, you may be able to measure things. Now that's the domain, forgive me for shifting metaphors again, of what I'll call vertebrate history. In that domain, you can describe things in a structured way. Insofar as the past has dates, we can describe it in a structured way. Our accounts of the past are vertebrate, they have a skeleton, and that skeleton is provided by dates. So that's the area that corresponds to vertebrate history, and most history is in fact vertebrate history. Then there's the dark area. Now, the dark area historians, of course, routinely ignore. I mean, how can you deal with something you don't know about? The dark area corresponds to what I'll call invertebrate history. Even if we can get glimpses of things in there, they have no real shadow, no real structure, no real shape. So this is the domain of what I'll call invertebrate history. There is a borderline, a very interesting borderline. I would say that geology entered that borderline in the 19th century. It's a dangerous area where you're tempted to think you have more illumination than you really have. Eusebius in the 4th century constructed a chronology of everything, using the begats in the Bible, the genealogies in the Bible, to argue that God created the world about 4000 BCE. And that chronology, as you'll know, had a huge impact on thinking in the Christian world for the best part of 2,000 years. This is dangerous territory because it may invite overconfident attempts to reconstruct what's in the dark area of the cave. Normal history, what historians normally do, is to operate in the illuminated area. They deal with vertebrate history, that's what Collingwood was saying. What I think maybe they don't do enough is think very hard about what the dark area may contain. Is the dark area, does the cave go back a huge distance? Is the bit we can see typical of the rest of the cave or completely atypical? Is what we can see most of the cave? Now that's the implication of Eusebius's chronology, that vertebrate history, roughly speaking, corresponds to the whole of the cave, because now, of course, we know that most of the cave was in darkness and was very, very different. So thinking about the dark area is important. And this is one more way of saying that how we assign dates is incredibly important for our understanding of the past and history. Now, I'm going to make the grand generalization that historical thinking has gone through two chronometric revolutions. And the one I'll focus on mainly is, I'll call the second one, but let me go back in time to talk about the earlier ones. Before the first chronometric revolution I associate with writing, before that, in societies without writing, your sense of the time, of the past, there certainly is a vertebrate past, a past which has structure. It's based on oral tradition, of course. But I think this is a reasonable generalization, and again, the anthropologists amongst you can correct me, that though oral tradition can contain a remarkable amount of precisely captured information, its chronological precision tends to fall off quite rapidly within a few generations. So I think it's a reasonable generalization that in oral traditions of history, the vertebrate past extends maybe a few generations into the past. Then it, as it were, loses structure, it becomes invertebrate. And I think the Aboriginal Australian idea of dream time, actually an anthropologist concept which has been taken up by Aboriginal Australians, captures that. You go a few generations back into the past and your history becomes invertebrate. It loses shape, it loses structure. What writing did was provide a way of assigning reasonably reliable absolute dates that went back many generations into the past. So writing allowed extended vertebrate history many generations into the past and extended the range of vertebrate history. It did more than that, though. It also determined what we could see, because the type of illumination that writing provided illuminates only certain things. Of course, above all, it illuminates the world of elites. By definition, only literate people can produce documents. So we learn a lot about rulers. We learn more about males than females. We learn very little about, or most people in society. We learn very little about those societies without literacy. So it's a very warped view of the past that writing gives us. I had a nice quote from Buffon on this, which I'll spare you. But so this creates a sense of the past that extends back quite a way in time, that can be held fairly confidently, but is in fact very narrow. The other crucial thing about this sense of the past is it excludes the natural world. Animals don't write. So our sense of the past becomes a sense of the human past and a sense of elite human pasts. Now, this sense of what history is, again, this is a broad generalization, but I think it's reasonably acceptable, has dominated our idea of what the past is and what history is for the best part of 2,000 years. For the simple technological reason that writing was the only way we had of assigning absolute dates to events in the past, and therefore constructing a structured view of the past, the vertebrate history. Now, that remained true, and I was astonished when it finally dawned on me that this is true. That remained true until the early 20th century. I have let me just briefly quote Colin Renfrew on this. I had everything neatly prepared, and I'm now okay. Here we have Colin Renfrew. Before World War II, for much of archaeology, virtually the only reliable absolute dates were historical ones. Tutankhamun reigned in the 14th century BC. Caesar invaded Britain in 55 BC. Only through written records could you have absolute dates. You could construct relative dates, certainly, but only through written records could you construct absolute dates. H.G. Wells tried, of course, to write a universal history after the Second World War, but he is very clear that his history goes invertebrate before about the first Olympiad. So written records dominated historical thinking, and this idea of the past became naturalized. History became the past as seen through written records, with all the limitations that implies. And that became what historians do. Now, what I'm arguing, of course, is that the reason why we define history like that is essentially arbitrary. It depends on the technological fact that until the early 20th century, we could only provide absolute dates by using written records. Now, let me go on to what I'll call the second chronometric revolution. It occurred in the middle of the 20th century. And essentially what I mean by the second chronometric revolution is the appearance, quite rapidly, within my lifetime, of a whole range of new technologies for assigning absolute dates to events in the past. Let me just describe that revolution very briefly. It begins with radioactivity, the discovery of radioactivity by the Curies in the 1890s. In the first decade of the 20th century, Ernest Rutherford figured out very rapidly that if radioactive decay is a regular process, which it is, you can use it as a way of assigning absolute dates to events in the past. And in fact, he demonstrated this claim by taking an ore of uranium and dating it to 500 million years ago. That itself was revolutionary, because the conventional age for the history of the Earth at the time was about 200, 100, maybe less million years. It took quite a time for these technologies to be refined to the point where they could be used regularly. Willard Libby at Chicago played a crucial role in pioneering carbon-14 dating techniques. And that's why I say that it's not really until after the Second World War that these techniques begin to be widely applied. Now, I won't discuss all the details. The crucial point is that carbon-14 dating is simply a whole series of techniques based on radioactive breakdown for dating events in the past. Different materials allow you to date events at different scales. As early as 1955, Claire Patterson in the States provided a good date for the age of the Earth, 4.5 billion years. That was the first time we had a good date for the age of the Earth. Since then, a whole series of other techniques have emerged, and I won't discuss them in detail. They include dendrochronology. Not all are based on radioactivity. They include genetic dating, the whole range of techniques astronomers use to come up with this most astonishing thing, a date. This is what Stegers trying to do, a date for the origin of the universe. We're used to this idea, but you just have to think about how astonishing that is. 13.7 billion years. So, this is what I mean by the second chronometric revolution. The sudden appearance, since the Second World War, of a whole range of new dating technologies that allow us to assign absolute dates to events before written records. And the claim I want to make in this talk is that historians, at least, have not taken on yet the revolutionary implications of this chronometric revolution. So what are the results? Well, here's the first result. I talked about the cave. Written records, it's like lighting a fire in the entrance to the cave. It allowed us to see a bit further into the cave, but there's still a large area of darkness. We didn't know how large it was. What the chronometric revolution did of the 20th century is illuminate the entire cave. Not perfectly, of course, but they allowed us to see the structure of the past as a whole. And that raises quite deep questions for our understanding of the past and the nature of history. And in the rest of this talk, I want to explore those implications. We can now construct a vertebrate history that includes the whole of the past, that goes well beyond what written records can reveal to us. What does that mean for our understanding of history? Is human history still different? Can we maintain the distinction, which I think most historians still instinctively maintain, between history and the natural sciences? Or is there in fact one very large story? Should the universities be putting the historians in the same building as the cosmologists, for example? I'd love it. I'd love to see this happen. I'm not sure it's going to happen very quickly though. Now, I want to explore this. Collingwood is interesting. He wrote before the full implications of the chronometric revolution were apparent. He said, he was beginning to be aware of this. He said, should history catch all of nature in its net? He has a two-part answer. First, he says, since Darwin, we know that the natural world is also historical. So his first answer is yes. But his second answer is but. Natural sciences are about events, history is about acts. In other words, we have intentionality. This is what preserves the distinction between human history and the natural sciences. I want to leave that definition hanging in the air as I offer an alternative one. And I'm going to get at it through a question. And the question is this. If, in principle, we can construct a vertebrate history that goes back to the origins of time, that crosses multiple scales from those of cosmology to those of human history, what coherence can there be in such a story? Is this going to be just a sort of huge, ramshackle, chronological tale with no unity at all? Now, I'm going to argue that attempts to think this through have yielded some very interesting answers. Whether they'll prove durable, I'm not sure, but I want to describe those answers. And to put it very generally, the answer is this. There is a very clear and powerful and illuminating, unifying idea for a history at all these scales. And that is the idea of complexity. Fred Spear's written about this, quite a lot of people have written about this. So let me describe how the idea of complexity may provide a powerful, unifying theme, and one that suggests a new definition of what we mean by human history. Fred Spear, in his book on big history, uses the notion of regimes, borrowed from the sociology of Norbert Elias. And Fred argues that what you see at all these scales, from the scales of cosmology to the scales of human history, are regimes. Now, I'm going to offer just a common sense definition of what I think Fred means by this, what I would understand by this. You have structures with some degree of complexity. They appear, they have some degree of instability, eventually they disappear. Now you see these structures, these regimes, at multiple scales, from a human society to a galaxy or a star or an ecosystem. But these things appear at all these scales. So history at these large scales becomes fractal. You're seeing similar things at different scales, which raises powerful questions about the nature of the relationship between these different regimes. Is the similarity real? What drives it? What things unify regimes at all of these scales? Now let's go slightly further. Maybe this is just a mishmash of complex things, but actually there's a chronological aspect to this, which is that there are good reasons for thinking that in the course of 13 billion years, the upper level of complexity has increased. And this is disputed territory. Stephen Jay Gould famously argued against this, and I'm a great fan of Stephen Jay Gould. I think on this subject he was wrong. So let me give some reasons for taking this idea very seriously. First, there's a series of intuitive reasons. We know that the early universe was, by many intuitive definitions, really rather simple. Before about 200 or 300 million years after the Big Bang, you have hydrogen atoms, you have helium atoms, you have energy. You don't have people, you don't have stars, you don't have planets. Wait 13.7 years, 13.7 billion years, and you have all of those things. So here's just an intuitive reason for thinking that over time, the upper level of complexity has increased. Now, I put it deliberately like that. It's reasonable to maintain that most of the universe is extremely simple still. If you randomly put yourself somewhere in the universe and you grab a handful of something, what are you going to grab? You're going to grab a bit of cold vacuum. That's what you're going to grab. The chances of you grabbing hold of a person, for example, are extraordinarily remote. So complex things are rare, very rare, but the upper level of complexity in this universe has increased. Now here we're beginning to see a storyline right through this story. You could say the same thing with living organisms, I think, very reasonably, and this is a very respectable argument in biology. One more thing about these complex things, they have emergent properties. The new thing that emerges is emergent properties. So, as with more complex things, they have new properties. Now, let me talk a bit about the idea of emergence. I think it may be a very powerful one for any sense of big history. Emergence is fascinating, and it has this sort of magical quality that properties appear that don't appear to reside in the constituents of the thing you're making. Water's a wonderful, simple illustration. You can study hydrogen as long as you like, and you can study oxygen as long as you like. Combine them chemically into water, and you have properties that you're never going to predict by studying just hydrogen and oxygen. I'm going to... Jonathan, when did I start? I just want to keep track of time.
10:30.
Okay. I think I'm on track. Because I want to illustrate the idea of emergence from a Buddhist sutra, which may sound like a very unlikely source for this. It's a wonderful dialogue between a Buddhist teacher, Nagasena. I think we're probably going back about 2,200 years. I need to check this. And he's talking with the king of a Greco-Bactrian state, somewhere in Kashmir. And the king is Menander, known in the sutra as Milinda. Melinda organises a formal debate with Nagasena, and the issue they're debating is the self. Now, the Buddha famously said that the self has no reality. I'm going to argue that what he's really saying is that the properties we associate with the self are emergent in modern terminology. And here's how the dialogue goes. Any of you who've read Buddhist sutras will know that you're torn between thinking, my God, this is boring, and then the other side of it, you're thinking, there's this lovely, lilting, repetitive rhythm to all of this. I'll spare you most of this. So here's the dialogue. Menander says to Nagasena, how can you possibly say that the self doesn't exist? I know I exist. Nagasena says, he asked how the emperor had come to the meeting, and Melinda says, in a chariot. Nagasena says, then please explain to me what a chariot is. Is the pole the chariot? No, reverend sir, says Melinda. Is then the axle the chariot? No, reverend sir. Is it then the wheels, or the framework, or the flagstaff, or the yoke, or the reins, or the goad stick? No, reverend sir. And back and forth, and this goes on for several pages, which I'll spare. Then is this chariot outside the combination of pole, axle, wheels, framework, flagstaff, yoke, reins, and goad? No, reverend sir. Then, at this point, Nagasena effectively claims victory. I mean, if it was the 21st century, he'd be going, yes, like this. Nagasena says, at this point, then, sir, then ask as I may, I can discover no chariot at all, just a mere sound is the chariot. Now I think that little dialogue captures very nicely the magic of emergent properties. They don't reside in the constituent parts. They reside in the fact that constituent parts are arranged in a certain pattern. They reside, as it were, in the pattern. And again, I'm offering an intuitive rather than a philosophically deep discussion of this. So here we have an emerging story for big history. We watch new complex things emerge. The American astronomer Eric Chason has argued that maybe we can even quantify this. Now I'm going to discuss his argument rather tentatively because this is certainly highly disputed territory. His point is that complex things, particularly if they are in a non-equilibrium state thermodynamically, require flows of energy. If that's true, and I think this is not an idea that needs to be defended, that's hard to defend, Chason argues presumably the amount of energy flowing through a thing gives you a rough measure of how complex it is. And he does some back-of-the-envelope calculations whose payoff is basically that modern human society is fantastically complex. The energy flows per unit of mass, per unit of time, are absolutely massive through modern human societies and much greater than, say, through a star. This is counterintuitive, but it provides a sort of possible ranking order for complexity. Now, I won't go into his argument in any more detail, except to say one more thing. It's tempting to think the second law of thermodynamics makes this idea of increasing complexity problematic. The second law of thermodynamics portrays a universe that is running down. in which there's less and less energy to create complex things. And yet here we have a story in which things seem to be getting more and more complex. I don't think that's a real problem. All you need to make complex things is inhomogeneities or gradients of energy at the local level, and there's plenty of that. That's not a problem. Why should complex things appear? Again, this is not a deep answer, but even if we cannot find some sort of driving force towards complexity, time itself is likely to generate more complex things, and we can discuss that in more detail. Now I want to go back, and I'm going to end quite quickly, so I want to leave time for questions. By going back to human history. I've argued that since the second chronometric revolution, we have to see human history, that is to say, the domain that we used to simply call history, which now I have to qualify as human history. We have to consider the possibility that it's now simply part of a much larger story. Has it lost its distinctive nature? Have we lost the power to say that history is different? I'm going to end by arguing that within this story, I'm suggesting there are very powerful reasons for thinking that human history is strikingly different, and that those reasons suggest a new way of defining what makes human history different. So here's the argument. At a broad level of generality, we can think of four domains of complexity. We could get fancier or less fancy, and I'm going to suggest we think of the physical domain, studied by physics, the chemical domain, studied in chemistry, the biological domain, and finally the human domain. And what I want to do just very briefly is justify the claim that with the human domain we get new things, a new level of complexity, new emergent properties, and those are what justify the historian's sense that they are dealing with a separate domain of reality, even if it is, in some sense, part of this large fractal story. I'll develop this argument quite briefly, and I'm prepared to develop it in more detail later on. What grounds are there for thinking that human beings are radically different from the great apes, with whom, as you all know, we are genetically very, very close to chimps or gorillas? What justification is there for thinking we're different? Well, I think the best way of putting it is to talk about our ecological virtuosity. We're fantastically good at finding new ways of doing what every animal does, which is extract energy from the environment in order to sustain their complex structures. This is what all organisms do. We're significantly better than all other organisms at doing that, and that explains the astonishing flows of energy that we control. And I think that flow of energy, though of course most of it's occurred in the last 2 centuries, is a story that goes back to the deep Paleolithic. Now, how can we explain this? Oh, this adaptability, incidentally, explains why if we find new methods of extracting resources, by definition that means over time we're going to be controlling more energy and more resources. More energy and more resources can sustain greater complexity. So this should explain why modern human society is fantastically complex. Historians are dealing with entities that are much more complex than those that physicists are dealing with. I hope there are no physicists in the room. That's an idea designed to appeal to historians, and to explain why historians cannot come up with mathematical formulae. The reason is because the level of complexity they're handling is significantly higher than that of these other levels. Now the question is, how do we explain this? What is it about us that should explain this astonishing ecological virtuosity? And I'm going to run through the argument very quickly, and it's one I can attempt to develop in greater detail. My attempt to present it, and I don't think the argument is actually terribly original, goes like this. Adaptation is what makes the biological realm more complex than the chemical realm. Biological organisms can change over time. Darwin told us the basic mechanism by which they do that, and now we know the genetic basis of that mechanism through natural selection. So here's the first mechanism of selection. It dominates biology. It's is natural selection based on genetic change. Now there's a second way of adaptation that we often don't think of, because it's generally less powerful, and that's learning. When you have organisms with brains, in their lifetimes they can learn. That is to say, they can learn new ways of relating to their environment. But with most species, the learning accumulates in the individual brain, but not within the community or the species, because methods of communication between individuals, they may exist, but they're not powerful enough to transfer a large volume of ideas precisely from individual to individual. Now we turn to humans. Humans with symbolic language suddenly have the capacity to move ideas from brain to brain so powerfully that those ideas start to accumulate within the community. In other words, more is transferred than is lost. A lot is lost, we all know that, but more is transferred than is lost. So here we have a species where the experiences and the learning of the individual can be accumulated within the species. I don't need to learn again that a particular type of berry is fatal, because this knowledge is accumulated within the species. That, I will argue, is the core of our ecological versatility. We can share information, we can accumulate information, and I'm going to call that idea collective learning. So we have these three adaptive mechanisms: the genetic mechanism, the learning mechanism, and the collective learning mechanism. That's what makes us unique. That's why our species is continually changing the way it relates to the environment and adapts to the environment. So, let me end then. My argument is that this approach suggests a way of defining what human history is about. Human history deals with a new level of complexity. That's why it's a distinct field of study. That field has new emergent properties. The driver of those new emergent properties is what I've called collective learning. And this is a claim, I'm going to make it. It's a claim that outrages, quite frankly, most of my historian colleagues. But I'm going to make it nonetheless. It is that here we have a rigorous post-chronometric definition of what distinguishes human history from other types of history. And I'm going to make one more final remark in passing, which is that I've got a hunch, this would outrage my colleagues even more, by the way. I have a hunch that this set of ideas is close to a Kuhnian paradigm. Those of you who know the work of T.S. Kuhn will know what I mean by a paradigm. In other words, this is close to a scientific definition of what human history is about. Thank you very much. I'm now happy to take questions. I think I've left less time than I wanted to.
11:30.
Okay, so I'm very happy to take questions. Yes?
Can I just tackle you on fractal history?
Yeah.
I mean, you could say that this meeting here is a structured group with a particular purpose, and it could be a fractal of, let's say, one of the Chinese empires. But in fact, the whole point about complexity theory is if you put together many thousands of this group and put it inside the Chinese empire, the emergent property of the empire would create something rather different. So I think you're missing a lot if you actually miss the changes that emerge with factors of scale, interaction, and other such properties. So I think the fractality of this group is rather limited as a model for history. The whole point of emergent complexity is that as you bring together items, actually something new may emerge, and we need that understanding of scale.
Okay, then let me, I think, try and rephrase what I was trying to say slightly more carefully. When I say that, when I introduce the idea of fractality, it's a way of, a fractal view of the past, it's simply, I'm using it probably in a quite naive way, simply it's a way of saying these stories are not completely different. They are not so different. The story of cosmology is not so different from the story of human history that there's no common story to be told. There are similarities of various kinds, Now, the second half of my talk, I guess, was much more concerned to say, nevertheless, having said that, the differences are really rather important too. And that's the point at which I'm certainly keen to introduce the idea of emergence and to argue that different domains have very different qualities which justify the existence of different academic disciplines. So I think this argument has consequences for the way we organise scholarship and teaching. It means we desperately need to find ways of bringing different disciplines together. That's the fractal side, so that we can actually start seeing some of the similarities between these different domains. But then we also need to do the separate thing, which is to focus on the emergent properties which distinguish one domain from another. And I'm not sure if I've fully answered your question. But in talking about, I haven't, in talking about fractality, what I'm trying to say is there are some similarities that are rather important. And we need to be aware of that first before we go on to talk about complexity. So I'm happy to pursue this if I've not answered your question adequately.
Sorry, I was actually making it more specific to history. I think there is a fractal dimension, but it's rather limited in the sense that emergent complexity suggests that the scale of organisation will bring new properties. So therefore it would be a mistake to actually see the small in the large, because we can't study vast empires by looking at what's going on in this room, although there are some properties, but it's very limiting. And so I think that's an interesting perspective, that something else, complexity isn't, if it was only fractality, we'd have very little to study. We could just study a microcosm and that would explain everything. And it's the contingent factors, for example, plus the actual historical and spatial variability that brings interesting new developments in. And that's why I think emergent complexity must be more than fractality.
Again, I hope I'm not misunderstanding the question, but fractality exists at many different scales, and of course I agree with you. I talk about emergent properties at a very gross level. Within human history, I agree completely, and in fact, one of the ideas I'm increasingly attracted by, and I think it's an old idea, and I probably need to read my way into the sociological literature to find it discussed more thoroughly, is simply the idea that density of population is a crucial driver of new emergent properties. So yes, I have no problem at all with assigning emergent properties to village communities or city communities or highly networked communities. Yeah, so I don't think I'm disagreeing with you. I may be using the word fractal in a slightly misleading sense, but I think it's important to maintain a balance, a sense that there are similarities. For example, I've used the idea of collective learning. Now, I would like to argue that collective learning is present at all scales of human history, in all eras of human history. But it operates in very, very different ways. By definition, today, in a world where I can use a cell phone to talk to someone in China, I can swap information instantaneously, collective learning, though it also existed in the Paleolithic, is going to operate in different ways. And collective learning itself requires new emergent properties. And a clear sense of both the similarities and the differences ought to give us a better sense of the structure of human history as a whole. I think I was operating in a sort of much larger, I was making much grosser distinctions, but I think I agree with you completely.
Well, thank you very much for a wonderful presentation, David. I'd like to take you up, if you will not be surprised, on one particular point. You said that it would be wonderful to have history and cosmology in one building. Wouldn't it also be wonderful to have sociology and history in one building? There's so much that you said that I agree with, but also I can't help regretting that you do not refer to a great sociological tradition initiated by Auguste Comte in the early 19th century who also had a very good argument about the hierarchy of sciences corresponding to a hierarchy of complexity, and the hierarchy of complexity again corresponded with the hierarchy of specificity. So my point is not that I want to correct you on a matter of history of ideas, but it would be collective learning. There are so many barriers to collective learning, and one of the barriers to collective learning is this interdisciplinary split that is actually haunting such projects as your wonderful project of world history. So it's not so much a question, but I would like to just point out that there may be a greater intellectual convergence from various disciplines than you just suggested in your talk, and that may also make for stronger, and because intellectually we are quite far in this respect, and you've aided us a great deal in that direction. But what would be needed now much more is strong academic coalitions to push the project of big history further. That would be my comment.
Thank you, Jules. For those of you who don't know, Jules introduced from a sociologist's perspective, I guess, a course in big history at the University of Amsterdam. If I can, I'm not sure if I'll capture all the points you made. I talked about putting the cosmologists and the historians in the same room. That's just a cute way of saying that I think one of the implications of what I call the chronometric revolution is that there may be a case for, and again, it's not a terribly original idea, but it may be that the chronometric revolution increases the force of the argument for putting together a whole series of disciplines that are united not because one calls itself a humanity or a social science or a science, but they're united by their historical perspective. That's really all I was trying to say. I think as students of change in time, historians, cosmologists, and of course sociologists need to be talking to each other a lot more. With regard to your point about the sociological tradition, first, I'm a historian, and this is the point at which I retreat into disciplinary either expertise or ignorance. I'm talking very much as a historian, bounded by the limitations of the disciplines, but I think this is an argument we have to have each generation. It's an old argument. One of the ways of describing what I'm trying to say is that it may be possible now to argue the sort of points that many sociologists were making in the 19th century in new ways because of the chronometric revolution, and perhaps in more powerful ways, and perhaps in more persuasive ways. But I agree, a lot of what I'm saying is not new, but I think now may be a very good time to be going back to these old arguments, using this astonishing new tool provided us by the chronometric revolution, which is the capacity to construct a structured account of the past going back to the origins of the universe. Now, there was at least one more point you made, Jules, and I can't remember what it was that I was going to respond to.
No, I think you answered to my perfect satisfaction. Thank you very much.
So I guess the general point is I'm increasingly aware, in fact, as I try to put this big history project in a larger context. I'm very much aware that the project of universal history, for example, is a very old one. Augustine was doing it, and you find it in all traditions. Ibn Khaldun was doing it. So to rephrase one of the central claims I'm making, it is that when H.G. Wells tried to write a universal history, or Ranke tried to write one, and he's very clear that it's probably undoable because we just don't have the information. Now, suddenly, that problem has gone. We can do universal history in a way that was not possible before the middle of the 20th century. And that's, I guess, the revolution that the historians, at least, I think, have not taken on board properly, and I'm not sure how true that is of other disciplines.
Could you just elaborate a bit more on the methodological problems, research program-wise, that you will encounter when you put forward proposals of, PhD students or whatever? Given the fact that Professor Houtman here mentioned the gulf between, or the boundaries, bridges, possible bridges between sociology and history, given the fact that mostly the social sciences are suffering from what I would call the tyranny of parsimony, and the tyranny of parsimony and the illogic of chronology versus your logic of chronology. Could you elaborate more on the research program and methodological problems, where you say, well, what would a student of modern history, let's say from 1540-50 onwards, could research within the framework of big history?
It's a nightmare question. I was hoping no one would ask it. I periodically I talk to graduate students who've done I teach big history as a first year course. I would love to start teaching it more as a graduate level course. I periodically get sometimes very bright students. I sometimes get emailed by people saying, love the idea of big history, I want to do research, can I come and do a thesis? And I feel very uncomfortable because I think the structures of research and teaching at the moment make it so hard to do this, particularly for a young scholar, that I'm not quite sure what a research program for a young scholar would look like in this field. So I think there are probably many institutional barriers to teasing out the full implications of this chronometric revolution I've described it, or however else you want to describe it. And I think a lot about this. I wish I could think of neat ways of doing this, but attempts to collaborate in my own university, for example, with enthusiastic colleagues in biology and geology. We've had long discussions about this. They always break down when we start to talk about budgets. Who gets money for this or that? Now, again, I was having some difficulty hearing what you were saying. I'm not quite sure I responded to your question, but at the moment, I have a feeling it's extremely difficult to know how one could construct a research agenda for students in this field. I think there is another level, though, at which this sort of thinking can be extremely useful educationally. I think for many history students, the idea of some sort of fractality might be very helpful. The idea that, and this is one of the basic points I'm trying to make, understanding that the history of humanity is part of a much larger story, and that there are very interesting questions to be asked across all those stories. Some of them have a bearing on what we do when we function as conventional historians. I think opening out those questions may be one of the most useful things that a big history agenda can do at the moment. But I must admit, I feel I run into a brick wall when I start thinking about PhD programs in big history. I'm not sure at the moment quite what they look like. And you don't want to sabotage the career of enthusiastic young teachers. So I very often steer them into world history, which is doable, and say, but just keep your eye on this, and you might find that this perspective informs your world history scholarship in very interesting ways. Now again, I'm not fully sure I've answered your question. If I haven't, please.
You did. There was one question there. I thought it was more understandable one question.
Sorry. Well, it was more a comment. Probably brought about by Dutch Protestant breeding. But if I understood you correctly, the highest level of complexity is human society. The highest control of energy flows and the like is human society. And just hearing this, I couldn't help but have a certain amount of feeling of disquiet about this. There have been people who've said before that we are at the center of the universe, that we are the highest, whatever. It's more of a comment, not really a question. But if you have any...
Yes. Thank you for raising that. I'd love to respond to that. The way I phrased it comes partly out of teaching the big history course and getting responses from students. And when I first started teaching it, as I said, I began very naively. I thought this would be a lot of fun, starting with the origins of the universe. Then I began to realise that there are, as a teacher, you realise you were teaching messages you didn't realise you were teaching. Well, one of the messages I realised the best students were getting was of the total insignificance of human beings. Once they began to get a sense of the chronological and spatial scales at which we were talking, and some of them would say, well, why do you bother with the human part? It's so completely insignificant. And that began to really worry me. So I began to try to, just at the teaching level, not necessarily at the scholarly level, think, how can I respond to the really smart student who says that? And I realised that at the spatial and chronological scales, this is absolutely true. We're completely insignificant. But as I began thinking about complexity, I began to realise that now here is an area where it may be possible, and I'm deliberately putting it tentatively, to offer a very different argument. So this is the way I tend to present it to students, and I hope this is the way it came across in my presentation today. If you ask questions about complexity, then there are at least some interesting lines of argument that suggest that what we're part of, in being part of human global society in the 21st century, is one of, and I don't need to push it any further, one of the most complex things we know. I had an interesting discussion with someone working on the SETI project about this, and there's an interesting line of argument associated with, is it Fermi, I think, who was talking to early pioneers in the SETI project. He said, look, we've been looking for some time, but they've not shown up. If they were really there, there were quite good reasons for thinking they ought to have shown up. Now, he may be wrong, of course, but since his time, the SETI people have been looking even longer. Nothing's shown up. If that means what it might mean, which is that there are very few, or to put it in the language I've used, organisms capable of collective learning are staggeringly, perhaps vanishingly rare, then that's a line of argument that is extremely interesting. I don't want to put it more strongly than that. And I want to steer my students in that direction. Let me say one more thing. I am not talking about progress. I hope I've said nothing that implies that I think that complexity is better than simplicity. It's simply complexity. But it has all sorts of implications. And of course, I don't need to spell out the ecological implications of I mean, John McNeil's done it superbly in his book, of this staggering increase in our power over resources in the last few centuries. So for my students, I think this is a useful tool for thinking, let me put it that way, rather than an open and shut conclusion. I do raise the possibility that this idea of complexity perhaps puts us in a much more interesting position within this story, maybe not central, but in a more interesting position within the story. But, I share your disquiet about any story that puts us right back at the centre of the universe, and that's not quite what I'm trying to do.
Yeah. I think it's time for a coffee break. It's all very taken up.